Hello, everyone. I'm Sneha. I'm a senior cloud specialist at Oracle, and welcome once again to Cloud Clinic. And today I will show how to enable Exadata Sparse clones. We will see how we can reduce cost, gain agility, and achieve scalability with database clones for development and test. So the focus today will be on Exadata cloud infrastructure in public cloud. And just an important note, and it happens with everyone. In case I get disconnected, stay with us because this is a very interesting use case that I'm going to present today. So let's get started. Okay, so let's begin with database clone challenges. And I am sure most of you all have gone through this situation as shown in this slide. Okay, so firstly, the time required to clone from production to non-production environment. And it's not just the time, but the effort required by a highly skilled DBA. Thirdly, the limits to resources like your storage, your CPU, your memory that's required for cloning. And fourth, which is the most important, okay, that is the performance issues due to functionality testing. And the meme at the extreme top says it all, right? And all these issues usually occur due to the difference in the infrastructure, in the features, and of course, in the amount of data between your production and your non-production. Okay, so listed here are the use cases for cloning. I'm just put very few slides here before I take you to the live demo and on our system. But there are some things that I want you all to understand before we get going and understanding more into the Exadata Sparse cloning. So in case you have a requirement where you need to do, full end-to-end performance testing, then yes, you would definitely require an identical comparable system as that of your primary. You can also go in for the advanced snapshot capabilities, which is similar to third party. So we do have the ACFS snapshots on Exadata, and a lot of our customers are using that for non-production or for the UAT kind of clonings. But just one thing I want to mention here that it does not provide the Exadata offload features. And thirdly, the topic of today, which is the Exadata Sparse, which I'm going to show you, and of course, I will also share the benefits with you in the coming slides for the testing and development with snapshots. And the best part of this is you can do your testing with your Exadata smart features. So you can see and implement and work it around with all your Exadata smart features. Okay, so before I go ahead, just benefits which I'm putting here, no complex cloning methods. I'm going to show you how with just one or two commands, we are going to do this cloning very easy. Since it is very easy, obviously there wouldn't be a requirement of highly skilled DBA. Resolves time to refresh. As I just said, it is a very small command, okay, that we are going to put in. And that command doesn't take much time. It is the actual cloning for Sparse is around 30 seconds to 5 minutes, depending on your database. Then obviously, when we are going to use just 30 seconds or 5 minutes for cloning, then obviously the storage, the CPU, all these system resources would be required less, right? And overall, then thus, this is how you're going to reduce your cost, you're going to gain agility and achieve scalability. And we are going to explore more. Stay with me. Okay, so before I get going and showing you how to create it, let me just show you how the storage allocation is, because this is the main crux of how you would be reducing your cost, right? And how you can efficiently create more sparse clones and how you can achieve scalability, right? Okay, so as shown in your extreme list, your database clone, when you do a full copy, okay, you're going to doing a copy of your blocks to your block. So if you have a 10 GB of database, 10 GB of production database, your clone will be 10 GB. Now, suppose you have a requirement of having development test, 5 developments or 5 tests. So that makes it around 10 databases, right? So 10 GB will make it 100 GB of space you're using. But what if you are now going to have a database which is 10 TB or could even be more? So just considering 10 TB and you are going to have, you have to create 10 such clones, that's going to be 100 terabytes, right? And if you have 100 terabytes, that's your amount of space you're consuming, right? That's the cost. And to clone this 100 terabytes, you're going to invest in resources. You require CPU, you require memory, and you require the time and effort, right? Okay, so that is where we are going to do the savings. Okay, so you come to my extreme right, the Exadata snapshots that I've shown here in the extreme right side. The Exadata snapshot technology, it would not do a proper block to block copy of your data. Okay, so your data files will be referenced from your master copy, which I'm going to explain you what this master copy is. And your snapshots would just be consuming very limited space, and your data would be read from these test masters. Okay, thus making it very efficient. And since you're going to use very little storage space, you can clone a lot of databases, okay, on your existing or on your Exadata machine. So let's go ahead and let's venture out more. I've tried to keep it very crisp. Okay, just 4 main steps. And in the Exadata cloud infrastructure on public cloud, a lot of steps are automated. We are going to see what is automated. A lot of things is just at a click of a button, making life very easy. Okay, so 4 basic steps. You're going to create a sparse ASM disk group. This is very important. If you do not have a sparse disk group, you cannot do the sparse snapshot cloning. Okay, and this is created only during your VM cluster provisioning on Exadata cloud infrastructure on public cloud. Okay, we are not referring to Exadata cloud cluster or on the on-premise. Secondly, you have to give access control to your disk groups. So your disk groups is your data disk group and your sparse disk group. So there's a very simple command to do it. Access underscore control dot enable attribute has to be set to true. Thirdly, you have to create a test master. Now, this is a very important point. You require a full copy. Okay, that would be required coming from your production. Okay, so this can be also your standby. You can convert your standby also to your full, cloned copy, which we would call as a test master. Obviously, since the data is coming from production, ensure you mask it. It's very important because you're not taking or you're not using or you're not showing your developers or testers, you're not exposing your critical data. Okay, your critical data like the user's personal information or the credit card information, the address, etc. All the important data has to be masked on this test master. And the last point over here in 3 is you have to have it in read only. Okay, so if you remember the previous slide I shared, there are pointers from the sparse disk that goes to your test master for reading. So that's why the test master has to be in your read only. And we are going to show this in the live demo, how you put it in read only mode, why you put it in read only mode, etc. And the last, obviously, where you would be using your development and your test, your UAT, your refreshes, your smart, your Exadata, sparse snapshot clones, okay, for your development and test. And the best part of it is you're going to use all the features, okay, out over here. So let's go ahead, let's explore. So you can do it at a full database level. Your database can be a CDB, it can be a non-CDB, or you can do it at your PDB. The best method or the recommended is being on a multi-tenant environment, using and doing it on a PDB. That's very simple, very easy, and very quick, and that is what I've covered up in the demo. In case you all don't have a PDB, you all don't have a multi-tenant environment, that is fine. You can always, convert your environment to multi-tenant. So if you have a production which can be an Exadata and which might not be, you can even have a Spark system. You can have them, you can take your data, replicate it with methods like OCI, GG, and have it converted to your PDB, to your multi-tenant environment. Then use it as a test master and create the multiple sparse databases. So I've shown an example here and at the PDB level, and this is what we are going to use for our test case, and for the demo today. So very simple. Diagram looks complicated though, okay, and I will take you through this diagram again, but this is at the PDB level. So at my extreme left, I've got my production database, which is the PDB2. So I'm just taking my pluggable database 2 from my database, main database. I'm replicating it to the cloned PDB, that is PDB2 underscore rep, that's at my center. Then creating my test masters, because the use case here which I am showing is like they require a cloned copy every month And from that clone copy, they require around 9 to 10 databases, snapshot databases. Okay, so you imagine if this is huge data, if this is around, as I just said, I won't even say huge, it's just 10 TB of data if I'm referring to. And if I have to make, 10 terabytes of clones, okay, that's around 100 terabytes of clones, and I'm not going to use that space. I'm not going to use 100 terabytes. I'll hardly use 10 terabytes for my test masters, and then the rest would be just very few GBs. Let's explore more. Stay with me. Okay, so this is going to be, how you're going to monitor it. I have put the commands for you in case you have to use it. I will also share the scripts, and all these things will be available. You can reach out to me to understand more on this, though I would be showing it in the demo ahead. So we'll park it later because I am covering this up, but there are scripts how you can monitor the data, the reco, and the sparse disk group that is required for your snapshot cloning. And I'll quickly blush through the additional features that's available with this. As I said, you just don't need to, it's not that you have to create a full copy. If you have a standby database, you can use it, okay? Unless your RPO and RTO is not going to get affected, right? So you can convert your test master and use it. You can convert your standby database into a test master and use it to create your snapshots. Okay, you can take sparse backups. You can take backups, as I said, of the sparse databases. And a very important thing is you can take hierarchical snapshots. So what you do is you already are creating snapshots from your test masters, and then you're creating multiple developments or test systems from those, from the parent parent snapshot. Okay, so these are the use cases, like, development releasing nightly build of the database, or the tester creates a snapshots and finds a bug, and he needs another clone to test it. In real time environment, this would be challenging, right? Just imagine, because a tester wants a database, separate database for testing. A 10 terabytes database would take probably an entire day for cloning, if you don't have the right system. Okay, so these are few of the use cases in case of having a hierarchical snapshot. And then I've just put here again a diagram here just to make it simple so that you understand. Now, when I create the sparse snapshot, right, I'd shown at the initial slide, I now make this as parent, and I can create another sparse snapshot which reads from this parent. Okay, so if it cannot find data, it will read from the test master. And so on, I can create more. Okay, up to 9 such sparse snapshots in a hierarchical method can be created. Okay, so let's go now. Let's go to our demo. Give me a moment. I'm just logging in. Okay. Okay. So we are now on our OCI. I'm going on to the Exadata environment on public cloud. Okay. Let me just show you my environment quickly. Okay, so I have an X8M machine. Let me go in. Okay, I'm using a 2-node, 3 storage servers, approximately 149. Just consider it as 150 TB as of now, because I'm going to show you how you're going to use it for the calculations for your sparse storage, which is important. Okay, so I've already created a VM cluster, because once we provision the infrastructure, we require a VM cluster to be created. So I'm going back here and I'm going to show you, since I've already created here, I will just go to the screen and show you where you can create your sparse snapshots. Okay. Okay, so no problem. 1 minute. This is for our infrastructure. We are going to the cluster. Create your VM cluster. Okay, there we go. Okay, so you see your configure Exadata storage. this is where you're going to mention your sparse. So you see your usable storage allocation, you have data 80%, record 20%, and sparse 0%. Okay, so we require sparse space, right? And I told you it's super easy to create the sparse disk groups here. So I'm just going to click on the allocate storage for Exadata sparse snapshots. Okay, and you see the change. I've got 20%. I'm showing it again. Okay, I'm clicking it here, and I'm going to allocate 20% of sparse disk group. So this is all automated. In case of your on-premise, you actually create the disk, you provision it in a different fashion, but this is just at a click. Okay, and then you create your Exadata VM structures. In case you have local storage, then yes, it will be reduced by another 5%. Okay, and when we say this 20%, so we have data at 60, reco at 20, sparse 20. Remember, I showed you my infrastructure, which was having approximately 150 terabytes. So that makes it 90 terabytes for data, 30 terabytes for reco, and 30 terabytes for my sparse. But the sparse is provisioned like as virtual, so you actually would be seeing 300 terabytes of space. That's a huge space, right? Okay, so this is how you can enable it. And let me go back. I'll have to just use the PPT slides. Okay, so this is where we are. Remember the 4 steps I'd shown, the creating the creating the sparse positioning. So we are here now. Okay, just give me a moment. Okay, so let's go back. I'm canceling this here. Okay, so I have already created and provisioned the sparse disk group. Let me show you my environment. Let me show you my database. Okay, so this is my VM cluster. So whenever you create your sparse snapshot, you will be able to see this as enabled. Okay, so storage for Exadata sparse snapshot is enabled. So as I mentioned, in my infrastructure, I had 2 nodes. So I have 2 compute nodes, and I would be logging in for this demo from my first node. I have around 14 databases that's running on this. For the demo purpose, I'm going to use the sclone database, which is a 19C database. And, we actually have a lot of features that's come up in 19C, even with respect to sparse and PDB clones and all. So in case you all have not yet moved on to these kind of the latest versions and still hooked on to the old versions, yes, please plan, because most of the old versions like the 11 and 12, is out of support. Okay, so this is all on our UI. Now I'm going to take you to the main crux of our demo today. So let's go there. Okay, I'm showing you the space again. I have logged into the grid environment. To make things simpler, I've just put in small scripts, so we don't have to waste time putting the commands. In case you require any of these commands, reach out to me. You can contact us through the various options that Violetta has already mentioned. Okay, coming to this. Okay, so remember the slide I had shown. So if you see, we have the data, which is approximately 90 terabytes, reco approximately 30 terabytes, and sparse, just check it down here, 30 terabytes. But we are seeing a virtual space of 300 terabyte that is given to you. Okay, the virtual space that's allocated. Okay, so now that was the first step. Now let's go to the second step. So that's enabling the access underscore control. Okay, so this is a prerequisite. You have to enable it on your data C1 and sparse snapshot. So let me go here. Okay, so if you see this, I have made this attribute, this value is now set to true. Very simple command, has to be done through your grid environment, logged in as ASM. Okay, so I've listed the commands here which you can use. You also have to add this to the data C1, but since you are in the Exadata cloud infrastructure and public cloud, this is already available by default. So this step is not required. Only the first step is important. Now, let us go to our Oracle environment. Let us provision the databases. create the Sparse, and let's see how, how quickly you can do it. And just, I think I forgot to mention you all on one important thing. Recently, I had done a proof of concept for a bank. Okay, they had around 10 terabytes of data that had to be cloned, multiple clones in an environment. So they required the development, the test. There were around six, if I'm not mistaken, there were six such clones that we had to do. And from the 8 terabytes, after we had the test master, which was made available with the setting of OCI/GG from a Spark to an Exadata environment, when we did this mask clone, it took us between 27 seconds to 30 seconds per clone, So that's at a lightning speed, right? And since it was not using 8 terabytes for the Sparse, okay, we could achieve scalability. We could create more and more sparse databases. Okay, so let's get back to the commands. Let's see how we create it. Okay, I am switching back now to the slide. Okay, so we are going to create a full clone here, and when I come here, the confused slide which I'd shown initially. Okay, so my PDB to just assume that this is my production. I'm having the PDB2 under rep. This is my, this is streaming. This is replicating continuously. You can make this, as a test is running out of space. Okay, but the wise thing is just keeping one very healthy copy as your replicated database, and then creating your test masters. From test masters, having your smart snapshots up to 9. Okay, so you can have 9 such test masters created from April month. Okay, so now I've just created April. So it could be like I'm creating a test master in Jan, creating test master in Feb. It could even be daily. Like the use case here was for monthly. You can have it at daily. You can have it at weekly. You can have it after 6 months. So that depends on your requirement. Okay, so the use case here is I'm creating it at monthly level. I'm creating a test master, and then from this test master, I have requirement to create multiple sparse databases. Okay, in case as I'd shown, I need hierarchical. Then from dev, I can create another 9 sparse hierarchical databases. Okay, so let's go here, and from the PDB2 rep, I'm going to first create a full clone test master underscore April, and I'm going to put it in read only. So let's do it. Okay, so if anyone wants these commands, wants help with these scripts, reach out to us. Okay, so if you see this create pluggable database, testmaster underscore April from my replica database. And of course, since I am in my OCI environment, I'm using TD, which is mandatory. So I'm specifying my key store password. Okay, so I have a full clone database now. I'm opening it and then putting it in read only. So you see, I'm having a test master that is created and put in read only mode. So that was my step 3. Okay, so I can apply my data masking and all that. So when you are using it in development and testing, yes, you will have to do this and then make it in read only. Now let's go to the main part. Okay, let's do these sparse databases. Okay, so I'm going to create 2 sparse databases, one for development, one for test. Okay, so just look at the command. Okay, so I'm creating a development for April. From my test master April, I'm using my sparse disk group. So this is very important. You have to consider the sparse disk group to have this, this technology to use sparse snapshots. Okay, and mention snapshot copy. So this is all that you are going to use to do your cloning. Okay, and of course, then your TD, the key store password. Okay, and these are now open. I've created 2 in read write mode. Okay, this is though for just for the demo purpose I use 4 GB, but reiterating it, I've tested this out on the recent POC for the bank with 8 TB 27 seconds. Okay, so it's that super quick because you're not doing a block to block copy, right? Okay, so let's get going. Let's see. Okay, so let us create, because I would require to do some purging and dropping to show you some more activities here. Okay, so I'm going to create now. Suppose we are in the month of May, and the requirement is again to create sparse this for the month of May. It could be daily, as I said. So let's create some here so that I have another database, to show you all some more activities besides the sparse clone. Okay, so we are creating another test master, which is a test master underscore May. Going back. Okay, so I'm creating the test master underscore May, and from this test master underscore May, I would be creating the development and the test. Okay, let's go back. Okay, so it's created a full clone, and you can actually imagine the time I would take if I was doing a manual cloning. Okay, and the effort as a DBA I would require. So I have my test master made available now. I'm in read only. I'm creating 2 more sparse. Let's do it. Okay, so the same command. I am doing it now for 05. For me, I'm creating dev and test. You see this sparse snapshot. I'm doing it in the sparse disk group. It's very quick, hardly seconds to create and open my database. Okay. So I have my database available. It's available in read write. So I'll be having test dev 05 and dev 05 and test 05 for the month of May. There you go. Okay. So I have a development 05 now and test 05 for the month of May. And as I said, you can have 9 such clones. Okay, you don't need to just restrict it to 1 or 2. You can have for your development, test, your UAT. I remember when 8 years back I was handling one of the major petroleum account. We had around 800 plus databases, out of which around 15 used to be refreshed daily. And that time the value was like the data was 5 terabytes. So these kind of requirements, where you have to do daily refreshes with multiple databases, and you have lots of data, this kind of sparse cloning, okay, you will really be able to achieve the 3 things that I've mentioned, reducing cost, very efficient, you can gain agility, and of course achieve scalability. Okay, so let's get going now. Now I have shown you how to do this test master. I have shown you how to create the sparse. Okay, but what if a developer wants to create some additional, table space? He wants to push in, so he want to create some additional objects, and that is obviously a requirement, right? It's a read-only database. Can we do it? Yes, we can, right? Okay, so it's very simple. I've just shown some commands how we can create this in the sparse. So what happens in such a case? Okay, so this, when you create additional objects out in sparse, any unchanged data will be read from your test master. Okay, so whatever changes are being done and would be used in your code for your reading, for your jobs, for your SQL queries, all this will be read from your sparse. Okay, so whatever comes here will be read from your sparse database. If you're querying these rows that you have entered, okay, this will be from your sparse database, and the rest will be from your test master. Okay, let's see ahead. Okay, so now I will also show you, in case you want to do a hierarchical clone, right? I had shown you, right? Let us switch to the slide. The hierarchical clones that I mentioned, I'm making my current database as a parent, and I'm creating multiple sparse databases. Okay, so when you have bugs or you require to save your copies, and create more copies, so this is very efficient and very quick. You can easily do it. You don't have to depend much on spending time to do clones. So let's see how we do a hierarchical cloning. It's again going to be the same process. Okay, so if you see here, we are going to do it the same way. The command would be the same. It's just that we are going to put our parent database in the read-only mode, and we are going to create the pluggable database from our sparse database. Okay, so here I have shown that if there is a requirement for weekly snapshots, okay, weekly cloning, then you can take it and do it from your parent snap database. Okay, so if you see this, I have created this, which is in read write, and I have taken this in read only. So whenever I'm going to use it for my development or testing purpose, unchanged data will be picked up from your parent snapshot and also from your test master. Any changes you want to do, you can do it because it's a read write database in your SEDev underscore 05W1. Okay. Now that we have seen DDLs, we have seen all this how to do the hierarchical. What if you want to convert the test master and reuse it? Okay, it's in read only. I need to make it read right now. Okay, so let me show you how to do this, and this is a very important concept. Okay, so stay with me. I am going to make this read right. Okay, wow. Okay, mounted, read write. No, we ran into error, right? Okay, so you cannot directly make your test master database into read write. You have to drop your sparse disk and manually change the permissions before you make this to read write. And let me show you how you have to do it, so that in case you implement this, you are aware of these and you don't land up into any corruption with your fresh clone copy. Okay, so I'm going to drop my sparse databases that I've created. So I'm doing this for the test master. Okay, so I have dropped the 04. You see the 04 are gone. And now I'm going to change this to read write. Okay, so you see this command over here. I have done, I've given a read write permission to my data C1 to all the data files which are yours. So I have brought them back. I'm getting them back to the read write state so that I can open my database as a read only. As a read write. Okay, so let me open this. Let us see if you're getting the error. Okay, so you see we have now brought this database to read write. Okay, so now this particular thing is also very important, because in case you want to refresh, you want to still go ahead and make some savings in space. Okay, then you can make this to read write and you can reuse this. If you have especially the OCIGG configuration that's being said, that makes it much more simpler. So I can open this. I might not even require an additional PDB2. I can directly reuse this with an OCI production, or if I'm having a standby, which I bring it back to a standby mode. Okay, so let me just summarize what we have seen. Give me a moment. Okay, so as I have shown here, it's very simple to use, right? I could create so many databases within no time. And imagine, you're doing a cloning on terabytes of database, and even no matter even the small databases, if you are just going to invest your 27 seconds of time in cloning with just a simple command, it is really very beneficial, right? And on an Exadata environment, we have a lot of smart features. Okay, you can reach out to us and we can take you through the smart features that we have, and that all is available in your sparse technology, in your sparse cloning. And these are very space efficient. I've shown it to you why they are space efficient. You have support for CDB, PDB, non-CDB. We can do it from enterprise manager support. It's in the roadmap, yet to be released. Hierarchical snapshots. Okay, so all these technologies, especially like hierarchical snapshots and all, you might not find it with other vendors and even with other cloning methods. Okay, and yes, these are space efficient backups. So that's it out over here. So just reach out to us in case for any issues, and we'll be there to help you out. Yeah, thank you.
for this great demo and presentation. There are some questions in the Q&A which we are trying to answer at the end. So let me, before I do the wrap up with the useful resources and assets that you guys can use, I would like to launch a poll right now, kindly asking you to provide your answers. They are very helpful to us, to make us, of course, to improve our work and to learn what you would like to see more within cloud coaching events. So I will leave you about 1 minute or so to provide your answers. Then we can move on with the session. Meanwhile, let me just move to the useful resources part. All right. See already some good answers. Speaking about Boost, so we have added a question in the poll. If you would be interested to actually attend to a Boost session. What is Boost? Boost it's a short call that you can book with presenter. For today, we have Sneha to discuss on the topic. You will see a link that we're going to share on the public Slack soon. So you can access it and book your session with Sneha. You can discuss, of course, things related to the topic that we cover today. We don't cover any support related issues or any other pricing details. And this call cannot replace a current workload discussion. So we're going to share the information soon. Thanks a lot for your interest in attending Boost call. As I see, most of you would like to see more Oracle database sessions, so we will make sure to include a DB session in every month from now on. And I see some of you would like to see more on cloud cost governance. Keep in mind that this month we're going to have, I think on the 27th of July, we're going to have a dedicated session on cloud cost governance. So keep an eye on our page and sign in. There is the registration button is already available. We're going to have also a security session in 2 weeks from now. All right, I think that's enough for the poll. Thanks a lot for answering all these questions. So let's do a quickly wrap up on the available resources that you guys can use. First one is, as I already mentioned, is our page. You can go there to register for upcoming events. By the way, we host events weekly, every Wednesday, same hour, 11 a.m. CET. Next week, we're going to have a session dedicated to OCI. So it is named Start Your Log Observability on Oracle Cloud with Less Effort. So if you'd like to learn more about how to actually automate logging in OCI Analytics service, you are invited to sign in. And more other resources with links. So we've added for you links to either the OCI available documentations and trainings and to the free OCI certification that is still given by Oracle University. And some other resources with links that you would like to check. So we have added a repository with short videos from which you can learn about cloud concepts and available services, and more other links. All right, so let's have a quickly look on the Q&A and maybe pick some questions. Sneha, would you like to answer live some of them?
Yes, sure.
So I see Marco here asking if those commands for cloning can be used in on-premises 19C DB.
No, not the ones which I have put here, because you require an Exadata machine. Okay, this is specifically with Exadata, and then you won't get what you get on the cloud, right? Like the first step, as I mentioned, is just a click of a button. You are enabling and creating a sparse disk group. So you won't get this kind of automation on-premise, but yes, you can do all this, what I've explained, but there are different commands for it. And I would be happy to share if you can reach out to us through a mail.
All right. And one more from Smail. It is about data disk group store in the production data files. Okay. Control and make it read only. So it's about if we can make the control and make it actually read only or write back. Okay.
No, I've not got the question, Violetta.
So if you check the Q&A, there is a question coming from Smail. Okay. He's asking if the data disk group store the production data files. If the data, yeah.
See, this is ideally not to be used in a production environment. Okay, please use this for non-production environment. That's the recommendation.
All right.
Yeah.
Okay. I think we covered pretty much all the questions. All right. So if no further questions, I would like to thank you all for attending the call today. I would like to thank you, Sneha, for presenting the session. And of course, we are waiting you on upcoming events. Thank you and have a great day.